But here's the idea with this helicopter drop activity. This is the template. I've actually cut one off already, but there's a number of helicopters in the same template. You'll see a couple of different lines on this. You'll see these very small dotted lines, and they will typically have a scissors symbol on it. So when you see these small dotted lines, you're going to cut those lines. When you see these larger dashed lines, those are folds that you're going to make. So we're going to have to make some cuts, and we're going to make some folds, and then we're going to end up creating this this helicopter. So let me cut off this top one here. So I've already cut one off here, so I'm nothing to trim off of the top here. But let me trim this along this line here, and so there's the basic helicopter. So now what I'm going to do is I'm going to cut this line here to separate the blades. So these are going to be the blades. So let me go in here with my scissors. Come along here, and I'll only cut it down to the dashed line, because the dashed line is where I'm going to fold it. This is one blade of the helicopter is going to go this way. The other blade of the helicopter is going to go this way. So it's going to look something like this when it's all done. Now what we're going to do with the bottom part is this. There's another line that I'm going to cut in, and I'm just going to cut part way in over here. I'm going to do the same thing on the other side. I cut part way in. So that's the line here, and then I'm going to fold along this dashed line, the heavy dashed line. So just fold along there. Probably easier to do it on a table, but I've got to do this for the video camera. So there, I'm going to fold that one over there. I'm going to do the same thing on the other side. Fold along the dashed line, and then. So that's like that, and then I'm going to fold this up here. There's one more dashed line over here where I fold the bottom up, so that's going to hold it all together. And then the last thing I'm going to do is I'm going to attach a paper clip. And probably the best way to do that would be just sort of across like that. So this is going to be your helicopter. Your helicopter will look something like this. And then I'll show you what we're going to do as we drop it. So here's what we're going to do with this activity. Again, we've made this. You should have made this helicopter look something like this. The blades fold over. I folded the thing in, so I've got a nice slender bottom part, and fold it up. And then I can put a paper clip. The paper clip is going to add some weight, so it always this will always fall down below the rest of it. So this is what we're going to do. So then what we're going to do is we're going to sort of make sure we drop it from the same height each time. I drop it, I measure how long it takes to fall, then I'll drop it again from the same height, always. Measure the time. Drop it again, measure the time, and do this, I would say, a good 4 or 5 times. And the whole point is we're gonna take those 4 or 5 times, and we can calculate the average time and say generally it takes maybe 2.3 seconds to fall. And to calculate an average, it's fairly simple. You take the first observation, add the second time, the third time, the fourth time, the fifth time. So say you do it 5 times. So take the stopwatch measurement that you took for the first one, the second, third, add them all up. You'll get a total time, and divide by that number by 5. That's your average time. So then you've got a time for dropping with one paper clip. Then what you're going to do is we're going to add a paper clip. Now before you drop it, you're going to make a prediction. The prediction is, okay, I think that adding a paper clip should make it fall faster or fall slower, or it shouldn't make a difference. And here's why. We've got to provide a reason for our prediction, our guess. It's not just a guess, it's a prediction with a reason. We call this a hypothesis in science. So we say, okay, I think it's going to fall faster because, or I think it's going to fall slower because, or I don't think it's going to make a difference, again, because. So you come up with all of that. Then, of course, after we've made their prediction, then we go and test it. So now I've added a second paperclip, and I let it fall. I'm not going to drop it here because I don't want you to get a sense of what's going to happen until you do it. That's for you to explore. So you're going to drop it from the same height and say, okay, drop it with 2, measure it, drop it again, and again, all with 2 paper clips. Get 4 or 5 measurements. Take the average of those and say, when I've got 2 paper clips, it falls in. It takes this long to fall. And then we're going to add a third paper clip. Drop it again, 1, 2, 3, 4, 5 times. Find the average time and say, this is how long it takes for a 3 paper clip helicopter. And I would add up to 4 paper clips because you want to see a couple of data points, or a number of data points to look for a trend. So now that I've got an average time for 1 paper clip, I've got an average time for 2 paper clips, an average time for 3, an average time for 4. If you want to do 5, then if you have time, the more data you get, the better the sense you get of what the effect of the paper clips is. So now, if you look at that handout, the worksheet, there's a graph on the last page. The purpose of the graph is this: that if I put along the bottom axis, the x-axis, if I say at 1 paper clip, I'll record the time on the y-axis, right? So at one paper clip, it fell in this time. And then I go over here at 2 paper clips. When I had 2 paper clips, it fell in this amount of time. 3 paper clips, this amount of time, 4, and so on. Now the thing is, what we should expect to see is if the paper clips made it fall faster, it should take a higher time the first time, get lower and lower and lower. So we should see the line sort of drop like that. That would be if the time is decreasing generally. It might not necessarily be a straight line. We have to take a look at that and see if because maybe it might curve like that, it might go like that, it could go like this, but we would see a general tendency of it dropping if it was speeding up. If it made no difference, I would take the same amount of time with 1 paper clip as 2, as 3, as 4, so I'd see this sort of generally horizontal line. And then the third option is if it's going to increase the time because it maybe can't spin as fast, or whatever reason that we think would cause it to take more time to fall, then we should see the time sort of increase. This is what we're looking for. But the only way we'll get to know if it is making a difference or not making a difference, and how it's making a difference, is if we make the observations, write down the observations, and then look for the pattern in the data. So I got some feedback from your teacher yesterday saying that you guys found it a little bit difficult. I was hoping maybe the description on the worksheet might not be the best way to go about this. So I thought, here's a video to watch. So look at this video, try this thing out, see if you can see a pattern happening, because this is science. And you're going to see more of this as you go through this course. You should be seeing it. There's a biology unit. When you do biology unit, you're going to look at ecosystems or life systems, depending on the course that you're in. You're going to make some observations and look for patterns. When you build electrical circuits, you're going to make some observations and look for patterns. When you start playing with chemistry and chemicals, you're going to make some observations and see if you notice any patterns. This is what we do in science. So do get used to it. Don't give up on us. It should be, I think it's a fairly simple task in terms of what it is that you've got to measure, but there's a lot of interesting science happening as a result of this. So give it a shot, see how it goes, and then we'll have a new activity for you on Thursday and Friday of this week, and as we move forward.